Hello everyone, welcome to this video. In this video, we are going to explore the two important definition of probability, and we are going to use the definition to calculate the probability. The first definition is the classical or theoretical probability. So let's explore what is classical or theoretical probability. In classical or theoretical probability, each outcome in a sample space is equally likely. So we assume that the outcome of any experiment is equally likely. An event, so here we define one more term, an event. Event is any combination of the outcomes. So if we list the outcomes, then that is what is called the event. So here, this probability, consider that the chances of getting something in an experiment, if there are more than one, they are equally likely. So the probability of an event E is defined as probability of event E equal to number of event or number of outcomes in event E divided by total number of outcomes in the sample space. So this definition is the classical or theoretical definition of probability. Here we need to know a couple of things. When you calculate this ratio, NE, that is number of outcomes in event E, divided by NS, the total number of outcomes in sample space, this result is between 0 and 1. So it can be 0 or it can be 1 or it can be anything in between. So the probability cannot be less than 0. That means your probability cannot be negative. And probability is at most 1. It cannot be more than 1. So your probability is normally between 0 and 1. And sometimes it is 0 and sometimes it is 1. When you see probability of any event is 0, meaning of that is the event is impossible. But if the probability of event is 1, meaning of that is the event is sure to happen. That is a certain event. If probability of event is 0.5, then we say that the event A is equally likely. So there are even chance of happening or not happening that event. If the probability is 0.25, which is close to 0, meaning of that is the event is quite unlikely to happen. But if your probability is 0.75, which is close to 1, in that case, we say that the event is likely to happen. Here is an example based on the classical definition of probability. A card is drawn from an ordinary deck. We have to calculate the probability of getting these. So whenever we talk about the ordinary deck of card, always remember that there are 4 different types of cards. And this one, if you see the card of this type, the first type of cards, they are here. They are called club. The second type of cards that you'll see here, that is the spade. Third type of cards that you'll see here, these are the heart. And the fourth type of cards that you'll see here, these are diamond. So this picture that I have shown here, this is the sample space. So you can see there are 52 cards in all. And then here we have 13, here we have 13. So total 26 black cards and 26 red cards. There are 4 different type of cards and 2 different color. Now the first one is we have to find the probability of getting a club. So according to the classical definition, the probability of club is equal to number of club. So if you look here, the number of clubs that we have in all is 13 divided by the total number of cards here is 52. So the probability is 13 over 52, which is 1/4, or if you change it to decimal, 0.25. You can see that this probability is between 0 and 1. So it cannot be more than 1, it cannot be negative. You can leave it as a reduced fraction like this, 1/4, or you can change it to decimal, 0.25. Next, we have to find the probability that the card is a rate card. So we want to find the probability that it is a rate card. If we use the classical definition, there are 26 rate cards, 13 here and 13 here, 26 rate cards out of 52. So 26 out of 52. If you reduce that fraction, 26 times 1, 26 times 2, so 1 over 2, or 0.5 is the probability. For the third, we have to find or calculate the probability of getting the 7 of heart. So probability of getting 7 of heart. So this one, we have to find how many 7 of heart are there. These are heart and we have only one 7. So it is 1 out of 52. So it is 1 over 52. And if you change that to decimal, you should get 0.0192. So that is the probability. Next is we have to find the probability of getting a king. So here you can see the cards start with ace, then we have 2, 3, 4, 5, 6, 7, 8, 9, 10. Then we have jack, then we have queen, then we have king. So here we are looking for probability of getting a king. Probability of getting a king equal to total number of king. We have 1, 2, 3, 4. 4 out of 52. Which is same as 1 over 13. 4 out of 52 or 1 out of 13. So you can change 1 out of 13 to decimal now, and that is 0.0769. 0769. Okay. Now the last one here, we have to calculate the probability of getting a face card. So probability of getting face card. Face card. You can see here, in each type of cards here, there are 3 cards with a face. Here is a face, here is a face, here is a face. So if you look at these 3 cards, they have the face. So there are 3, 1, 3, 3, 2, 6, 3, 3, 9, 3, 4, 12 face cards. So 12 out of 52. And if you reduce that, you'll get 3 over 13 or 0.2308. So here we calculated the probability using the classical definition of probability, and in each case we saw that the value of the probability is between 0 and 1. Now here is the second example on classical probability. When a single die is rolled, find the following probability. So when you roll a single die, the sample space is S equal to, when you roll a die, you may get a 1 or a 2 or a 3 or a 4 or a 5 or a 6. That is the sample space. Here we have to find the probability of getting even numbers. So probability of getting even numbers is equal to, okay, now we have to find how many even numbers are here. We have 2, 4, 6. So there are 3 even numbers out of a total of 6. So 3 over 6 is half or 0.5. Next, we have to find the probability of getting odd numbers. So probability of getting odd numbers is equal to, we have to find how many odd numbers are here. That is 1, 3, and 5, which is 3 out of 6, which is half or 0.5. Third, we have to find the probability of getting an 8. So probability that the number you get, the number is equal to 8. So how many 8s are here? We don't see any 8 out of these 6. So 0, 8 out of 6. Meaning of that is equal to 0. So the meaning of this one is when you roll a die, the probability that you'll get 8 is 0 because you will not get the 8. This is the uncertain event, or this event is not going to happen. Next, we have to find the probability that the number is less than 7. So probability that the number is less than 7. So here, how many numbers are less than 7? There are 6 numbers which are less than 7 out of 6, which is equal to 1. So meaning of that is the probability is 1. Meaning of that is the event is definitely going to happen. Whenever you roll a die, you'll always get a number which is less than 7. Okay, continuing with the classical definition of probability, let's add one more definition here. And here we want to define the complementary events. The complement of an event E is the set of outcomes in the sample space that are not included in the outcome of the event. So meaning of that is, for example, if this rectangular box shows all the elements in the sample space, this or this, then if the quantity inside this circle is the event, then everything outside the circle is the complement of that. Okay, so the complement of an event E is the set of outcome in the sample space that are not included in the event. And this is how we represent the complement. The complement of an event E is denoted by E bar or E prime or E with C on the top. And there are few interesting formulas that you need to remember for the complementary event. The probability of event E and probability of not E, because the event and the complement are opposite of each other. So probability of event plus E plus probability of not E is 1. That means if you simplify this and you want to find PE, the probability of event E is 1 minus probability of not E, and probability of not E is 1 minus probability of E. So in next example, we are going to use one of these formula and solve the problem involving complementary events. Here is that example. It was found that 25% of people were victims of violent crime were ages 25 to 30. If a person is selected at random, find the probability that the person is younger than 25 years or older than 30 years. So here what we are considering is, we are considering from age 0 and then up to 25 and then up to 30 and older. So here probability that these people, okay, in this age group, probability that the people in this age group are or were the victim of violent crime, they found that it is 25% or 0.25. 0.25. So if we consider the victim of violent crime as our event E, let's say this is my event E, then what they have given is, they have given that probability of occurring event E is 25%, but we write probability as a number between 0 and 1, so that is 0.25. Now what we have to do is, we have to find the probability that the person is younger than 25, younger than 25 means here, and older than 30 here. That means the person in this age group, younger than 25 years or older than 30 years, is not included here. It is not included here. That means this event is the complementary event. So this is complementary event. This is your complementary event, which we write as E prime. And we have to find the probability of that. So what we know is probability of the event E plus probability of not E or complement of E is equal to 1. Let's substitute the values. So probability of E is 0.25, 0.25. Probability of not E or complement of E, we want to find that because we are asked to find the probability that the person is younger than 25 years old or older than 30 years. And this is equal to 1. So if I want to find probability of not E, then I have to subtract 0.25 on both sides. So minus 0.25 here and minus 0.25 there. So if we subtract, this will get cancelled. We have probability of not E on the left hand side, and that's equal to 1 minus 0.25, which is 0.75. So the probability that the person is younger than 25 years or older than 30 years is 0.75. That is the probability that they will be the victim of a violent crime. Now, the second definition of probability, which is called the empirical probability or statistical probability. The difference between the classical and empirical probability is that the classical probability assumes that the certain outcomes are equally likely. So that is the assumption in the statistical, the empirical, not the empirical, the theoretical probability. But in empirical probability, we rely on actual experiment to determine the likelihood of the outcome. So for example, if we flip a coin 10 times, the theoretical probability considers that you'll get head 5 times and tail 5 times, but that is not going to happen. If you flip a coin, you may get head 7 times and tail 3 times, or you may get head all 10 times, or you may get tail all 10 times, or you may get head 2 times and tail 8 times. So this probability, the empirical or statistical probability, depends on the actual calculation or actual result of the experiment. And the way we calculate this probability is probability of any event E is equal to F, that is the frequency for the class, like how many times you will get the head, divided by n, that is total number of frequencies in the distribution, or how many times the experiment is performed. So for example, over here you can see, suppose when we perform first set of experiment, suppose we get head, okay, we get heads about 75%. When you perform second set of experiment, suppose we get head about 65%. Suppose we perform the experiment for a certain number of time, we get 50% of the head. So you can see that the values goes up and down. But if we perform the experiment for infinitely large number of time, if you keep doing that experiment over and over again, and over the time, what you'll see is you'll actually get 50% head and 50% tail. So what we say is, when the number of trials are infinite, when I say infinite, it's many times. Maybe you're tossing your coin throughout your life doing nothing, something like that. The empirical probability approaches the classical probability, and we call that the law of large number. So when we talk about law of large number, meaning of that is when we perform an experiment infinitely many times, then the probability of getting something, or the probability of any event E, can be calculated either using the empirical or the theoretical probability. The result will be the same. So we are going to take an example on how we can use empirical probability to calculate the probability of certain event. Here is that example. A company is conducting a phone survey of randomly selected individuals to determine the age of social networking site users. So far, 1,000 social networking site users have been surveyed. The following frequency distribution shows the result. So here is 15 through 25, 175 of them use social networking sites, 26 through 45, 410, 46 through 65, 320 of them, above 65, 95 of them. And when you add all this, it is 1,000 because 1,000 of them were surveyed. Now we have to find the probability that the user is the age between 26 and 45 years old. So probability that the user is in this age group 26 through 45, that is equal to f divided by n. The frequency for this class 26 through 45, the frequency is 410 divided by 1000. So when you divide that, this is equal to 0.41. Okay, so the probability that the user is in this age group is 0.41. Now the next one is we have to find the probability that the user is below 65 years. We have this one, above 65 years, 95. So meaning of that is probability that the user is above 65 is 95 out of 1000. So 95 divided by 1000 or 0.095. This is 0.095. But what we have to find is we have to find the probability that the selected user is below 65 years. So above 65 years is this. So below 65 years and above 65 years are complementary event. So if I want to find this, the probability that the user is below 65 years, what I have to do is I have to subtract this probability from 1. So probability that the user is below 65 is equal to 1 minus 0.095. So that is equal to, okay, that is equal to 0.905. That is the probability that the user's age is below 65. So this is how we can use the statistical probability to find the probability of any event E. So this is the last example in this video. So you have seen that in this video we learned how to find the probability using the classical and statistical definition of probability. I hope you like this video. Thank you so much for watching.